Okay, so in this chasing problem, now we'll try to find the radius of curvature of the path that this particle B takes with respect to point A. Suppose the particle A is moving with a constant velocity u along x-axis and particle B is moving with a constant speed v, but is always directed, the velocity of B is always directed towards A. So the positions at t equal to 0 is shown in this diagram. We need to find the radius of curvature of the path of particle B with respect to A at time t equal to 0, means just after the start of this motion. Okay, so with respect to ground, let us look at this situation with respect to ground. So initially at t equal to 0, A is having a velocity u which is always constant, and the velocity of B is towards A, which is equal to v. Now, since the speed of particle A is constant, so particle B is not going to have any tangential acceleration. We are looking at this situation with respect to the ground. Okay, so since the speed of B is constant, a particle moving with a constant speed will not have a tangential acceleration. It is only going to have a normal acceleration or the centripetal acceleration. And the centripetal or the normal acceleration is perpendicular to the direction of net velocity. So at t equal to 0, the velocity of B is in the upward direction towards A. So the net acceleration of B should be perpendicular to the velocity of particle B. Now, since particle A is moving with a constant velocity, so acceleration of particle A is going to be 0. So if you are looking at the acceleration of B with respect to A or with respect to ground, both are going to give me the same answer. So since we know tangential acceleration of B is 0 and the normal acceleration, we can write it as the velocity of particle B multiplied by the angular velocity of particle B. So this is the standard equation from circular motion, where centripetal acceleration you can write it as v square by r, or you can write it as omega square r, or you can also write it as v into omega. So this will be the net acceleration of B with respect to ground or with respect to particle A. Both are going to be same. Now we are required to find the radius of curvature with respect to particle A. Now with respect to particle A, particle B is also going to have a velocity of u in the left direction, right? Velocity of B with respect to A will be velocity of B minus of velocity of A. So there will be a negative of VA vector, which is u in the left direction. So the net velocity of B at this instant t equal to 0 is going to be the resultant of V and U, which is in this particular direction. So this diagram is with respect to A, right? And the net velocity of B with respect to A at this instant t equal to 0 is the resultant of V and U, which are perpendicular to each other. So we can write it as V square plus U square. This is the net speed. And acceleration of B with respect to A or with respect to ground is same, and which is in the rightward direction. We know the value of this is V times of omega, right? So radius of curvature, we know that radius of curvature will be equal to net velocity square, right? The square of the net velocity of a particle divided by the component of acceleration which is perpendicular to the net velocity. So you can see that the net velocity and the acceleration of B with respect to A, they are not perpendicular to each other. We need to find the acceleration, the component of acceleration which is perpendicular to the net velocity. So the component of acceleration perpendicular to net velocity, I can write this as V omega times of sine theta, right? So this will be the acceleration perpendicular to the net velocity with respect to point A. So the radius of curvature can be written as net speed square, which is v square plus u square, divided by the perpendicular component of acceleration will be v into omega times of sine theta, right? So in this expression, what is the value of omega at t equal to 0? So with respect to A, the particle B is having an angular velocity. So you know that angular velocity can be written as the velocity perpendicular to the line joining A and B, which is u, divided by the separation between the particles at that instant, which is d. So at t equal to 0, at the situation you can see over here, the value of omega is simply u divided by d. And the value of tan theta, which is this theta is the resultant of V and U. So I can write the value of tan theta as V divided by U, right? So we know the value of omega, we know the value of tan theta. So if this is the value of tan theta, what is the value of sin theta? So I can write that sin theta will be V divided by under root of V square plus U square. So I'm replacing the value of omega and sin theta in the expression for radius of curvature. So radius of curvature will be V square plus U square whole divided by V times of omega, which is U by D, into sin theta, which is V divided by under root of V square plus U square. So we'll get this value as V square plus U square power 3 by 2, right? Divided by, in the denominator, you can see we are left with U into V square. So U into V square, and there is a term D. So this will be the radius of curvature of particle B with respect to A at t equal to 0. Now, if the question had asked that what is the radius of curvature of B with respect to ground, right? If we needed the equation of radius of curvature with respect to ground. So an additional point you can note in this question that if radius of curvature at t equal to 0 with respect to ground is required. Okay. So with respect to ground, you can see radius of curvature, net velocity of particle B with respect to ground at t equal to 0 is V. So V square divided by the acceleration of B with respect to ground is already perpendicular to the net velocity. So it is simply equal to V omega. So this will be V divided by omega, and you know the value of omega, which is U by D. So I can write this as V by U times D. So this will be the radius of curvature with respect to ground. And this expression will give me the radius of curvature with respect to point A at t equal to 0. Okay, so if you have understood this question, you can give a try to slight variation of this, that what will be the radius of curvature of the path of B with respect to A at an instant when the angle between the motion of A and B is 37 degree, right? So A is going towards right and B, the instantaneous velocity vector of particle B is towards A. So when the angle between V vector and U vector is 37 degree and the distance between the particles is 4 root 5 meter. So at this particular instant, what is the radius of curvature of B with respect to A? You can take the value of U as 5 meter per second and the value of V as 10 meter per second, right? So we'll come up with a solution on this part in the next video or some other video.